We dropped his name already a couple of times. Marc Goldschmidt, Senior Vice President of Remanufacturing and Overall Technologies, is going to join us. And he's going to talk about how he developed from this field, this business area, from efficiency to sustainability, and going through this journey that I was just discussing, right? More or less.
Absolutely. Thanks a lot for the introduction. And I'm very happy to join today the conference and share some insights about our company and how we are progressing. But before we start, picture this. We're in a workshop. It's late in the day. A technician goes into an area where an old engine is, and the engine is rusty, it's written off. Basically, it's scrap at the end of the day. But now he takes out a device, he does a quick scan, and he gets a full story of the engine. What is worn, what is still strong, how can we upgrade performance, how much CO2 can be saved when we reuse. A few days later, that engine is returned back to life. It was fast, within a couple of days. Circular thinking made it possible, and digital tools made it obvious. I think this is what we should talk about. Yeah, how do we combine different things, lean, circular, and digital opportunities with AI? And what I would like to do is now to share with you, where are we in this journey? Are we already there, what I try to picture for the future, or are we at the beginning or in between? And I think at the end, we can discuss a little bit about where are we exactly and what have we learned out of the journey we have taken. When we go to the next page, so let me try to get this moving. So to give you a little bit context, what is Rolls-Royce doing? We are not producing cars anymore. The cars have been sold to another company. But we are producing basically as a big company engines for aeroplanes. But I'm coming basically from the power system side, where you can see in the middle, we are producing engines and generators for power generation. So every third click in the internet is backed up with our solutions. We have industrial equipment, mining trucks, for example, or we go also into the governmental business, which is right now growing as well. Company have delivered last year a significant growth again, about 5 billion. And we have a total workforce about roughly 10,000 people working in these different applications. So everything basically what can be moved, not on the street, is energized or supplied by us. So when we go a little bit more in depth now into circular solutions, I can't give you the exact detailed number, but what you can assume, it's a significant, huge amount of 3-digit million contribution to the overall business in turnover. We have installed a fleet of 150,000 units in the market, and some of the examples we are powering you see below on the pictures. The workforce working in reman and overhaul is about 650 people. A huge amount of this workforce is working in one of the 16 sites. There are 5 regional centers. Our strategy is that every continent has basically a reman center, meaning there is one huge center, for example, in the US. We just installed this for 70 million euro. We have a site in APAC in Singapore, which acts as a regional center. And then we have another center here in Germany, which has somehow a leading role, acting as well as the lead plan for the overall network. Our portfolio consists of different solutions. A couple of them are highlighted because I want to go in this one a little bit more in depth. But you can sort out the portfolio into 2 big areas. The one area we love the most is preventive. So we do everything well ahead before something gets broken. Or if a customer has an issue, we also can for sure repair engines or components individually. What stands for us a little bit out is the left part. It's reman solutions, where we mix components and build up new products with these components. Basically, this product gets a new serial number, it's a fixed price, and it's a defined lead time, which is in some areas very, very short. And then we do as well, when we do the remanufacturing process, an upgrade on the latest specification we have received from the R&D teams. Meaning every component is double-checked, is a newer version available, and we upgrade component-wise to bring it on the highest standard which is available at this point of time of the remanufacturing process. In between, you see as well some other solutions, like overall solutions. The difference to reman is that then the serial number of the product stays the same, and the customer gets all components reconditioned back to his individual serial number he has delivered to us. I think the overall core of the whole process is the core management system. You can also call this as a deposit system, meaning whenever we sell a product or define new components or new engines, we sell them with a deposit between 20 and 30% roughly. It's nothing different like a Flaschenpfand, like a deposit, like a bottle. When you buy bottles in Germany, you also have to pay this deposit. And we do the same basically for our products in order to ensure that our reverse supply chain is all the time filled with good returns. How does it work? We sell the product with the deposit. The customer has a time of 1 year to return the other product in the field back to us and gets this deposit then on his customer account paid out. When he sends back the engine, the product, it goes in a core collection center. In the core collection center, we do a technical review of the product with checklists. They're digital available. We take pictures for documentation. And when everything is in shape how it should be, the customer gets the full deposit back, or we do deductions. For example, if components would be missed or something is broken, then we do as well deductions on the deposit, because we want to ensure that everything is returned back in good shape to be remanufactured again in the next cycle. Then the product stays in the core collection center without any movement at the beginning. When there is then the demand there for exactly this kind of core or for components of this core, we pull this engine into the reman center. We start disassembly, we start reconditioning, we send components to vendors we have, and get as well then in return reconditioned components for vendors back. We go again in production, and then we sell this either directly to our customers back or through service partners as well. This model is also available. When you look on return rate, you see this on the right side. The return rate is fluctuation year by year a little bit. On the engine side, roughly everything can be covered. And on the component side, a little bit more is going into the gray market. But there are also very good projects in the pipeline to increase the level here again over time. I think besides the exchange program, another dimension everyone should consider is having budgets for buybacks. This would be another dimension. So if there is not a deposit anymore available, then as well you can buy from the market components back to clean out or to dry out the gray market. Now we go a little bit more in depth. We move in the biggest center we have. We go to Magdeburg. The footprint is quite large. It's 20,000 square meters big. We have 4 test benches there. We can produce up to 800 units. It's also our lead plan for technology development, meaning everything about how we reuse, how we remanufacture, which equipment we use, what are wear limits, is driven out of the center. And the center was in the past, this building, a huge piece of a great German manufacturing company called SKL, Schwermaschinenbau Karl Liebknecht. They produce in a big industry sector, which you can't see on this picture, 3,500 medium-speed engines. When we go now one step deeper into our use case, we talk about rail power packs. You see here on this example how this product looks like. It's either available to be assembled below the train, or it's also available as a solution to put on top of the train. It depends a little bit on the design of the rail company, of the rail operator, but these different approaches are available. Roughly of this product, we've produced in the last years 250 units per year. You see there are different types and variances available. And just to get a feeling for dimensions, how big is it? Is 5 meters to 2.80 to 1 meter. So it's not a small device. It's really huge, heavy machine building equipment. And it weighs up to 6.5 tons, which means that the footprint, what I showed you before with the 20,000 square meters, needs the size in order to lift in order to maneuver the equipment through the factory. We have in Germany 8 main customers. They deliver 80% of the volume to us. Interesting is, I think, as well to think a little bit about the time between overhaul. So they can run this equipment 18,000 units, operating time 20 years. And we are right now in a process to further extend that. As you can imagine, there's huge discussion in the industry and legislation in place to decarbonize. And I show you at the end a little bit as well, what are we doing in order to extend exactly this operating time. So one level deeper into this business, what we are doing here, you see the value stream. There's a little bit of design we use in lean manufacturing in order to show how this overall circle we've implemented is working in a nutshell. The overall throughput time from receiving the rail power pack till the end is 15 days only, 15 days. You must imagine a rail power pack needs to be assembled in a depot of a customer and needs to be swapped in short time when the train is in general in maintenance. That's why these 15 days is something we have to ensure. And you can imagine as well, when you recondition a component, an engine as part of the rail power pack, 15 days is not possible. That's why we have designed an approach where we work with refurbished swing components. You see this a little bit in the middle of the presentation here with this supplier visualized and inventory. Here we have swing stock installed for components which have a higher lead time, like the engines, the gearboxes, generator, or cooling systems, as a couple of examples. And then you see that the disassembly time is roughly 3 days, and as well, the throughput time in assembly is roughly 3 days. And then it goes to test dispatch within 3 days. And this is how we can achieve this shorter turnaround time of 15 days for the 250 to 300 units a year. So basically, it's a customer tech time of one rail power pack per day output. So with all these approaches, what I just showed you, we were significantly improving the last years 2 things. One was the output, because the market demand was increasing significantly to 260 units. Now it's even further growing. I shared with you, yes, OEM components were extremely important for us. Short throughput time, the lean principles, and doing continuous Kaizen activities to get the waste out of the flow. But on the other side, with the standardization improvement, we were able as well to improve the on-time delivery with a couple of additional elements like a rolling forecast. So we are connected with a slot planning to our customers in order to know exactly which product is coming when into our center, that not any slot is wasted with waiting time. And on the other side, what was also key for us was that the supply chain, which is also reconditioning components for us, is set up for these volumes. That's why we were able to grow this business significantly. But then what we have learned was something interesting. We had a change in quantities as well. And on the other side, customers was looking for something different, yeah? In the rail industry, there was also significant pressure on cost. That's why we have redeveloped or changed our approach. So meaning, on the one hand, we were looking into an improved configuration of the product, but also we were doing 2 additional things. One was improve the reuse levels and the reconditioning. And on the other side, we were working on digitalization and the application of AI. And this should be also a little bit of focus today to show you exactly what we have done in these segments. But before, it was important for us as a global team to set the direction and to get a clear understanding where do we want to move the circular solutions we are supplying. And this picture has been developed over multi amount of workshops, starting from first scratches. And I remember very good at the beginning, we had the Impulse workshop, and Corey also was joining there and giving a great speech to us. And this is the result basically on a high level. You see a lot of numbers also around. You see a hidden infinity sign with the two circles. You see our application. You see on the top the flags of the countries where we have operations. And you see a little bit of mission and a vision statement. What was important for us here was really get our heads, the leadership teams, the team leads behind where do we want to move. And it was really developed in a team effort to get clarity about our direction. And based on that, we were breaking this down into very specific use cases where we see opportunity to get significantly better and further grow. I just pulled out like 5 elements out of this circle we have developed. You see on the left side, the delivery center, which is key to visibility of the digital connected assets that we know which engine is when to be maintained. You see as well automated demand planning as a direction. You see as well the decentralized recycling. So for us, it makes no sense to return everything back to the core collection centers, to Aachen in the US or to Magdeburg or to Singapore, when we already know we can't reuse, we can't maintain this product because it is maybe mainly scrap. Yeah, that's why we want to save as well the transport costs around the world. That's why decentralized scrapping in the smaller centers is key for us. In the middle, you see remanufacturing. This is basically the core of bringing components back to life. We have installed a guided disassembly with digital disassembly, a bill of materials. We are measuring the real scrap rate. So we have a target on how much do we must win out of an engine and how much do we really achieve. We do reconditioning not only by machining components, we have also spray-on technology, or let's say high pressure cold spray is nothing different than when you go to a dentist and have a hole in your teeth that you can basically fill it up again. It's the same approach, but for metal, it's even more hard than the original product before. And then you see a little bit below some overlaying elements like preventive maintenance on equipment, so the machines. We used a tool called Digital Value Stream from a company which is, I think, quite innovative in this area, is Onic. For performance management, we use an application called Solunio to have KPIs visual of our progress. And in the facility environment, we have tools and applications to improve also our energy consumption using photovoltaic and other applications. You go then in the other two sections, upgrade and update. I will talk about this a little bit as well. And on the right side, you see circular engineering. I think this is really key, that products, from our point of view, must be designed for circularity. It's not helping you if you use very cheap glue approaches, because then you can't disassemble again. Yeah, that's why already when you design, you must think about how can you maintain as well. And this is what this team is doing. You see 2 other elements, AI-based analytics and smart reconditioning. And exactly on these 3 elements, I want to give you a small deep dive to show what is exactly happening in these areas. So the first element is increasing the level of reuse or circularity. Very, very classical. We're basically taking our rail power packs and doing disassembly workshops. Yeah, cross-functional team were coming to the shop floor. We reserved an area and we're doing basically step by step together disassemblies and reviewing every single component of the power pack again, knowing we already deliver very good levels of circularity. But with these workshops and improvements, we were even to take cost out. So we had before in the presentations as well the topic of hey, somehow we need to generate value with what you're doing. It's not only a hip thing we want to do, we must generate value. And we were taking basically exactly 23% of the cost out by, on the other side, even increasing the reuse rate as a new standard above 80% of a complete rail power pack. Important to understand this for us as well, that every power pack goes at the end of the process onto a test run and is tested like a new product and gets as well the same factory warranty like a new product, like 2 years. That's why for us, it's even better than new. What are we doing now is exactly, we have a digital bill of material, as I shared, and we measure exactly the scrap rate and how much do we win. And the whole plan steering is based on prefixes, meaning every single component gets a different prefix in SAP, so that we know, okay, this is a reuse component, this is a recondition component, this is a remanufacturing component with a drawing from R&D, this is a cooperation component from a vendor, because when you go on high scale, you need to be able to automate, so to say, the overall value stream in a digital way. Otherwise, there's a high risk that you mix up things, that you make errors as well. Going now a little bit deeper into how do we maintain or how do we analyze our components. You see here a very smart approach, which costs us only a little bit, like 2,500 euro. It's a small box. You put a piston in, and with a software and with an algorithm, we are able now to detect the wear. In the past, all these components were scrapped. And now we have the target to have a scrap rate only by 5%. And you see here on the right side, you see the difference of new versus used. And we are reading in with about 1,000 components into the model. What is a good condition of this piston and what not. And a human eye can't detect this because these small corrosions are so minimum that you can very easily make a lot of mistakes. And the good thing is even the software being applied is open libraries, and basically we learn the system what to detect with reading in, so to say, the different pictures. The other element is also, I think, a very good approach which can be applied in many industries is we have a significant amount of different part numbers, and the products we get are partly 30 years old, 5 years old, 60 years old. And many of these parts don't have any information on what is this part number. Yeah? It's too small, the part, you can't write a part number on it. That's why we had in the past years often a huge challenge to fully understand clearly, yes, this is the right part number. That's why we make up our mind, found a solution on the market to work with a 2D scanning system. And right now, we can reduce with this approach 75% of the identification time. And the software is globally available. Everyone can use it in the centers. It was a little bit more costly. We learned in basically the different components. And I did by myself many tests on different components. I must say some of them you can't see a difference at all. And the system sees the difference, gives us at the end a printout, a label. We can pack it and deliver it to the inventory. The good thing is as well on the other side, when you go later to assembly, you can't make an error anymore because you know exactly 100% it's the right component, and you can't make basically a wrong quality or an impact later on a test bench that you have to reassemble again with the right component. So there's also a very good approach to prevent delays in assembly or to de-risk quality issues fully. So, outlook. So this was the world of rail power packs we have maintained in the last years, but also from the original equipment side, there are new products now in the market and coming back to us. You see here on the right side an example of a Series 1600 rail power pack, which just started maintaining the engines and the rail power pack as well. There's a new product, and you see on the right side also like hybrid solutions with certain impacts for lower NOx emissions, or like a quiet drive mode when trains are going into the station, they can go full electric into the station, There's also, I think, a quite nice approach. Now you can say, yeah, but still it's diesel engine. Yes, you're right. But we have also invested very strongly into collaboration for alternative fuel types. And with HVO, hydrated vegetable oil, you can even decrease the CO2 emissions right now by 90%. And when you've maybe seen on the German railway some trains with visualizations, so the German rail organizations have approached us and tested this whole concept, and they are so happy about the results that we now see that the maintenance cycles are further extended long in the future. And the Deutsche Bahn, for example, do not have to exchange that quickly on electrical drives as originally assumed, because also significant investments are needed for that. So with this approach, you can achieve your targets. And on the same time, it's good for our business because we can continue to recondition and remanufacture, in this example, the rail power packs. So this is our journey so far. Reconnecting to the introduction, let's say we are not fully there, but we're moving quickly and applying digital and AI solutions to find improvements and next steps, which have not been before possible from our point of view. And I hope this insight was valuable for everyone. And now would be the chance to discuss or exchange a little bit on questions and give answers, hopefully.
Yeah, thank you so much for your thoughts and insights. I think it was a very inspiring keynote, and I wrote down your vision statement about disrupting the norm with closed loops ecosystem to achieve net zero. Whenever I talk to you, I already have the feeling that is the new norm, right? That is what you are doing. So you already have some steps ahead of maybe a lot of people who are joining the call. Being on this journey for quite a while, having a look back, what would you suggest for people who are now starting this journey? What are your recommendations on how maybe to promote such a case within the company, or how to start the journey?
So not only now for this journey, I think what is all the time helpful on the first hand to listen to conventions like this one, yeah, to get an insight what others are doing, but as well to find out where are companies who already have success and maybe make a visit and listen to these companies, how they're doing the things exactly in the same way. We did this also in other journeys. So for lean manufacturing, we did a lot of benchmark visits to learn from others who are far ahead. I think what we can see as well is some companies are ahead because the business model in general is enabling certain steps. Yeah, we are in a very high cost investment product industry, meaning this makes absolutely sense. Yes. When you now start with consumable products, maybe it's more challenging, yeah, to find exactly the sweet spot. Yep. But this would be my clear recommendation. Look around, understand what the companies are doing, and try to understand, is this fully matching your business model as well, or do you have to tweak and adjust and then develop your own approach? Also maybe with the one or the other expert, yeah, which gives you a neutral insight. This also helps, yeah. And at the end of the day, it must make financial sense, yeah. If it's making no financial sense, it makes no sense to start it, really.
Yeah, thank you. Was that an invitation to everybody who's listening?
For sure. I mean,
yeah, maybe we'll help organizing and finding a space in your schedule. But thank you so much for your insights, for being a benchmark also for others, now learning from others first, and now giving back, giving the opportunity to learn from your journey. Thank you so much for your time and being here.
Thank you.